Have you ever wondered how the northern lights are formed? Known as Aurora Borealis in the north, these lights are a captivating spectacle, painting the night sky with an ethereal glow. This light show is not just a beautiful mystery, but a fascinating scientific phenomenon. Now, let's delve into the science behind it. The northern lights occur when gaseous particles in the Earth's atmosphere collide with charged particles from the sun. These particles are directed towards the poles by our planet's magnetic field. When this celestial collision happens, it results in captivating bursts of light, creating the northern lights. The different colors we see, from green to red or even purple, depend on the type of gas particles that are colliding. So the next time you witness this spectacular display, know that you're watching a cosmic dance of charged particles and magnetic fields. Ever pondered over the formation of a tornado? A tornado, in essence, is a violent and dangerous wind funnel, a marvelous yet terrifying spectacle of nature's power. But what causes these swirling vortexes of wind and debris? The birth of a tornado begins with a clash of air masses. Warm, moist air moves upward, meeting cold, dry air descending. This encounter creates instability and a unique sort of tension in the atmosphere. The warm air continues to rise, and as it does, it cools and condenses, forming a thunderstorm. In certain conditions, these thunderstorms become supercells, characterized by their rotating updraft. It is within these supercells that tornadoes are born. The complex interplay of air masses, pressure, and temperature creates a spinning column of air that extends from the thunderstorm to the ground, wreaking havoc in its path. Tornadoes, while destructive, are a powerful display of nature's capacity for weather creation. Have you ever questioned why some creatures glow in the dark? In the deep, dark realms of the ocean or the dense undergrowth of the forest, you'll find organisms that produce their own light. This phenomenon, known as bioluminescence, is like a little magic trick of nature. Bioluminescence is essentially a survival tactic, a unique adaptation in response to the darkness of their environment. Picture this: when the world around you is pitch black, being able to produce your own light can be a game changer. But how does this happen? It all boils down to a chemical reaction. In the presence of oxygen, a substance called luciferin undergoes a transformation with the help of an enzyme called luciferase. The luciferin is oxidized, and in the process, light is emitted. This glow can serve various purposes, from attracting a mate to warding off predators. So when you see a firefly twinkle in the night or an anglerfish illuminating the ocean depths, remember this: bioluminescence, hence, is nature's own little light show. Ever wondered how a rainbow forms? Well, let's dive into the enigma of this stunning natural phenomenon. Picture this: a beautiful arc of colors sweeping across the sky. It's a sight that can make even the grayest of days feel a little brighter. But what's the science behind this captivating spectacle? In essence, a rainbow is a delightful dance between light and water droplets. When sunlight encounters a raindrop, it undergoes three significant changes. First, it refracts or bends as it enters the droplet. Then it reflects off the inside surface of the droplet. And as it exits, it refracts once more. But here's where the magic happens. Light is made up of many colors, each with a different wavelength. As it passes through the droplet, these colors spread out or disperse, creating that familiar spectrum we associate with rainbows, from red at the top to violet at the bottom. So a rainbow is a charming game of light and water droplets. Ever thought about what causes an earthquake? Well, it's a fascinating dance of natural forces that happens beneath our feet, literally. Earthquakes are essentially the Earth's surface shaking, but what's behind this tremble? Imagine the Earth's crust, a hard shell covering our planet, broken into several large pieces or plates. These plates are constantly moving, albeit very slowly, about the same speed at which your fingernails grow. Now, when these plates collide, slide past each other or pull apart, stress builds up. Eventually, this stress becomes too much. It's at this point that the crust breaks or shifts, releasing the stored energy. This energy travels in the form of seismic waves, causing the ground to shake. And voila, you have an earthquake. It's a powerful, sometimes destructive, yet entirely natural process. Earthquakes, thus, are a stark reminder of our planet's dynamic nature. Ever wondered what triggers a volcanic eruption? A volcano is not just a conical mountain with a fiery temper. It's a complex geological system where the Earth's molten interior, better known as magma, meets the surface, Volcanic eruptions are violent discharges of this magma, often accompanied by gases and ash. But what causes this sudden outburst? It's all about the movement of the Earth's tectonic plates. These massive rock slabs that form the Earth's surface are constantly moving, albeit very slowly. When these plates diverge or converge, they create gaps and pressure points in the Earth's crust. This allows the magma from below to rise to the surface, resulting in a volcanic eruption. It's a fascinating process, a testament to the dynamic nature of our planet. Volcanic eruptions, therefore, are a fiery display of Earth's internal heat, a dramatic yet crucial part of Earth's continual reshaping and evolution. Ever questioned the existence of fire rainbows? Well, despite their fiery name, fire rainbows aren't actually rainbows, and they certainly aren't on fire. Officially known as circumhorizontal arcs, these stunning displays of color are a rare optical phenomenon that can stop you in your tracks. They look like a ribbon of flame streaking across the sky, a delightful blend of colors that makes it seem as if the heavens have caught fire. But this majestic spectacle is the result of a complex interplay between sunlight and ice crystals. You see, for a fire rainbow to occur, the sun must be high in the sky, at least 58 degrees above the horizon. Then light from the sun enters flat, plate-shaped ice crystals in high-altitude cirrus clouds. This light is refracted or bent and then exits out the other side of the crystal, creating a prism effect in the sky. Fire rainbows, thus, are an enchanting spectacle of light and ice. Ever pondered over the formation of a tsunami? Imagine an enormous series of waves towering above the ocean surface, racing towards the shore. This is the spectacle of a tsunami, a powerful force of nature that captivates us with its raw power and immense scale. But what causes these formidable waves? The answer lies beneath the ocean's surface. Tsunamis are typically triggered by undersea earthquakes. When the Earth's tectonic plates shift suddenly, it displaces a vast volume of water. This displacement sets off a series of waves that surge away from the epicenter at high speeds. As these waves approach shallow water near land, their speed decreases, but their height increases, resulting in the towering walls of water that characterize tsunamis. The energy carried by a tsunami is immense, enough to cause widespread devastation when it hits the land. Tsunamis, while devastating, are a powerful testament to the force of nature. Ever wondered about the science behind geysers? Picture a bubbling spring, a sudden burst of water and steam shooting high into the air. This is the fascinating spectacle of a geyser in action. But what causes this dramatic display? Geysers are unique kinds of springs characterized by their intermittent discharge of water. But this isn't due to any whimsical decision by Mother Nature. It's all down to the heating of groundwater by Earth's magma. That's right, the fiery molten rock that lies beneath our feet. As the magma heats the water trapped in the earth, pressure builds up. When the pressure gets too high, the water and steam are forced out of the ground in a powerful jet. It's like a pressure cooker that's been left on the stove for too long, but on a much larger scale. And there you have it. Geysers, therefore, are a mesmerizing display of Earth's geothermal energy. Ever thought about the cause of a meteor shower? This celestial event, where a number of meteors radiate from one point in the night sky, is a sight to behold. But what's happening up there is more than just a beautiful light show. Imagine our Earth journeying around the sun, colliding with tiny fragments of space debris. These fragments, often no bigger than a grain of sand, are remnants from comets or asteroids. As these fragments enter Earth's atmosphere at high speeds, they burn up due to the friction with the air molecules, creating a streak of light we often refer to as a shooting star. But when Earth passes through a particularly dense cloud of this debris, we witness a meteor shower. Each meteor we see is a tiny piece of the cosmos making its final journey, burning brightly before fading into the night. Meteor showers, thus, are a grand space spectacle seen from our own planet. We've journeyed through some of nature's most fascinating phenomena. We marveled at the northern lights, understanding how solar particles and Earth's magnetic field create these stunning light shows. We unraveled the mystery of tornadoes, appreciating the role of differing air temperatures in their formation. We dove deep into the magic of bioluminescence, discovering how certain organisms generate light in the dark sea depths. We reveled in the enigma of rainbows, recognizing the role of light refraction and reflection in their creation. We grappled with the puzzle of earthquakes, comprehending the seismic activities beneath Earth's crust. We explored the intrigue of volcanic eruptions, acknowledging the pressure buildup from molten rock. We were spellbound by fire rainbows, learning about their formation from ice crystals in high-altitude clouds. We faced the riddle of tsunamis, understanding the undersea earthquakes that generate them. We admired the fascination of geysers, appreciating the heat and water pressure dynamics. And finally, we gazed at the allure of meteor showers, realizing the cosmic debris burning up in our atmosphere. The next time you witness these phenomena, remember the incredible science behind them.